Today we're going to be adding mixed numbers with unlike denominators. When looking at this problem, remember the steps that I gave you in the last two lessons. We'll be using the same steps. Step 1, if the problem happens to be lying down or horizontal, make sure you rewrite it standing up. Now, second step was to check your denominators, because they have to be the same in order to add or subtract fractions. In this case, they are not the same. That is the focus on today's lesson. What do we do when the fractions have different denominators? Well, we're going to use the same strategy we've used in the past with comparing fractions. You saw in a different video one way to do that is to create equal fractions that have the same denominator. So we're going to utilize that strategy here so that we can create two new fractions with the same denominator. In order to do that, the very first thing I would look at, and I would want you to look at, would be your largest denominator. Take a look at your largest denominator, which happens to be the 6, and ask yourself if it's possible that if you put 6 as your new common denominator, would it be possible to find a multiplier for both of these numbers? Since 6 already exists, of course, there's an easy multiplier here. That's going to be 1. And you can then do the same thing to the top. You'll see that when using the same denominator, it makes it quite simple to create equal fractions. It's going to be the same fraction. But it has to work for the other fraction as well. So you have to be able to find a multiplier. It doesn't have to be the same multiplier as the one below. It will probably be different. So in this case, can you just find a multiplier? So a number that will fit in this box that will equal 6. The answer is 2, of course. And then once you realize you can find a multiplier, then you know that 6 will work. So taking a look at the top part, you're going to have to multiply by the same multiplier, 1 times 2, as you did below, and you will get 2/6. Now you can see that we have two fractions with the exact same denominator, and we learned in 2 lessons back that we can now add our numerators, which is step 3. So we'll add 2 and 2 to get 4. Our denominator will stay the same. Step 4 is to add our 2 whole numbers. That would be 5 and 3, which gets you 8. Step 4 is to regroup or simplify. Regrouping would be necessary if our fraction here was improper, but our fraction is not improper. So the next thing to look at is our numerator and our denominator, and we need to now ask ourselves, is there a divisor that we could use? Something we could divide both of these by to reduce our fraction or to simplify it, make it smaller. We like smaller numbers, not larger. So looking at both of these numbers, we can see they're both even. So therefore, we know 2 goes into both of them. So we could divide both top and bottom by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And now we have a simpler fraction. We can always look at this new fraction and ask ourselves the question again. Could it be simplified any more? Is there a divisor that would both go into 2 and 3? And the answer to that is no. So then we are finished. These fractions are no longer needed, and our final answer is now our whole number 8 with our new simplified fraction 2/3. I'm going to walk you through this process one more time before you get a chance to do it on your own. Here we have 3 1/4 plus 2 3/5. Following our steps, step 1, rewrite the problem vertically. Already done that. Step 2, take a look at your denominators and make sure they're the same. Of course, these are not the same, so we need to come up with a strategy to make them the same. The first tip I could give you, again, is to take a look at your biggest denominator, in this case a 5, and ask yourself if 5 will work. Now before writing 5 in as your new denominator, you'd want to ask yourself a question. Is there some number I can multiply to 4 to get 5? You're going to need to find a multiplier that will get you from 4 to 5. There is no number. 4 will go into 5, but it won't go in evenly. So 5 is not going to be your best denominator. So the second thing you could do The easiest way to find a common denominator would be to multiply your two existing denominators. Multiply 5 times 4. Anytime you multiply two numbers together, the product will be one in which both of the multipliers will go into evenly. So if we multiply 5 times 4, we'll get 20, and we'll be assured, absolutely 100% assured, that it will work as a common denominator. It may not always be the smallest common denominator, but it will work. It would be best if we could find the smallest common denominator, and one way you could do that would be to start with your largest denominator, 5, and start writing out the multiples of 5. 5, 10, 15, 20. Maybe write the first 5 multiples of the largest denominator, and then check to see if there are any smaller numbers, smaller than 20, that 4 also goes into. If you wrote down your multiples of 4, you get 4, 8, 12, 16, 20. We're looking to compare and find a common multiple between these two numbers, and the smallest common multiple we could find, otherwise known as the least common multiple, or LCM as it's most notably remembered as, is 20. There is no smaller common multiple. So by multiplying these two numbers, we got a little lucky, and it happened to be the smallest. It is not necessary for it to be the smallest in order to get the problem correct. Now that we have our common denominators, we can now work on finding our multiples and our new numerators. One nice thing about using the strategy of multiplying your denominators is that you don't really have to guess what the multiples are. You know how you got 20. You multiplied 4 times 5. So your multiplier here will be 4. We know how we got 20 on the top by multiplying 4 times 5. So our multiples are easy to figure out when we're multiplying the two numbers. It's nothing new to figure out. So we'll simply do the same thing to the top as we do to the bottom of each of these fractions. 3 times 4 is 12. 1 times 5 is 5. And now we have two new fractions that are equal to their older fractions. These two are equal and those two are equal. But they have now the same denominators, which allows us to be able to add our numerators. So step 3 was to add the numerators. That would be 12 plus 5, which is 17. And our denominator will stay the same. Step 4 is to add our whole numbers, 3 and 2, which is 5. And step 5 is to regroup or simplify if necessary. So regrouping means that we're going to change improper fractions to proper. And do we have an improper fraction? When we look at our denominator and we understand that that tells us it takes 20 pieces to make a whole, we only have 17 pieces. So we don't have more than one whole, so we do not have to regroup. We can also now need to look at our numerator and our denominator to see if there's a way to reduce this. Is there a divisor that we could use that would reduce this to smaller numbers? It has to be a number that can go into both 17 and 20. And 17 is a special kind of number that we call a prime number. Prime means that there are only two digits that go into 17, 1 and itself. In other words, there's only two numbers you can multiply together to get 17. That's 1 times 17. Therefore, there are really only two numbers we can choose from, 1 or 17, because those are the only two numbers that go into 17. Well, we could use 1, but that wouldn't change the fraction. If we divide by 1, again, we get 17 twentieths, and that would be a waste of our time. And we can't divide by 17 because 20 divided by 17, well, that doesn't work. So there's no way to simplify this fraction, and our final answer is going to be 5 and 17 twentieths. Now I'm going to give you a couple problems to try on your own. Write this problem down in your math composition notebook. Solve it and come back for the answer. See how well you've done. Hopefully you started off with step 1, which is to rewrite that horizontal problem into a vertical problem. When adding and subtracting fractions, we always write them vertically. Second step would be to check your denominators. Of course, today's lesson is all about different denominators, so they're not going to be the same. And now we will see if you found common denominators correctly. The first trick I taught you was to look at your largest denominator, which is 4, and ask yourself if that would also work for our top fraction. Is there a number that you can multiply to 2 to get 4? There is such a number, so if you were to use your least common multiple, or LCM, least common multiple, then you would have used 4. However, if you multiplied them, you would have used 8. Nothing wrong with using 8. It's just going to require more work at the end. So, using 4, the bottom fraction, of course, the multiplier is 1. So the top number will be 1, and of course the fractions are the same. But on the top one, the multiplier will be different. It will be 2. And doing the same thing to the top changes our numerator. And now we have 2 fractions with common denominators. So we can move on to step 3, which is multiply your numerators. Our numerators are now 2 and 1, which gives us a total of 3. And our denominator stays the same. Step 4, add your whole numbers 2 and 3. That will get you 5. Our last step is to regroup or simplify if needed. Now, if you did not use 4 as your common denominator, you probably don't have 3/4 down here. It's likely then that you have 6/8. If you got 6/8, it's because you multiplied 4 times 2. 6/8 is not an incorrect answer, but it's not simplified. So you can see, but by using the least common multiple, we've actually saved ourselves a step. Step 5. We don't have to simplify 5 3/4. There is no divisor that will work for that, and it's not improper. But if you did not use the least common multiple, instead multiplied 4 times 2 and used 8, you got 6/8, which means that now you need to follow through with step 5, which is find a common divisor. In this case, the divisor would be 2. We have 2 even numbers, so 2 goes into both of these even numbers. 6 divided by 2 is 3. 8 divided by 2 is 4. And you can see that in order to get to where we got to, initially, you would have to divide. So this is the reason why you're trying to always find the least common multiple. However, you don't want to spend a lot of time staring at it than when there's one very simple, easy way to do it. That's just multiplying them. Either way will work. Just remember to always check for simplifying and regrouping when you're finished. Try one more problem on the next here. Pause the video, come back when you're finished, see how well you did. Alright, welcome back. Step 1 is already done for you. Step 2, check your denominators. Are they the same? No, they are not. Let's make sure that they are the same. Take a look at your largest denominator, 4. Ask yourself, will 4 work? If I were to put 4 as my common denominator here, would I be able to find a multiplier times 3 that would equal 4? No, you will not be able to find one. So hopefully you just multiplied 4 times 3, which will happen to get you your least common multiple. If you use 12 as your common multiple, your multiple down here would be times 4. Do the same thing to the top, and you'll get 4. Your multiplier on the above fraction would be 3. Again, finding these multipliers are easy because they're the opposite. These are the two numbers you used to get 12. So those are your two multipliers. Doing the same thing to the top here, 3 times 3 is 9. Now we have common multiples, or common denominators, and we can add our numerators, 9 plus 4, which is 13, over 12. You might notice already that 13 over 12 is improper. It's good to try to notice those as quickly as possible. We know it's improper because it takes 12 to make a whole, but we have 13 pieces, so we have more than one whole. If you remember how to change these, the question you'll be asking is, how many times does 12 go into 13? Of course, it's only going to go in one time. And then what would be left over? In order to find what's left over, you could just subtract. They are kind of already lined up. Or count from 12 to 13. There's 1 left over. And the denominator will stay 12. When we add our whole numbers, we get 5. And then we have to remember that we have a whole number 5 over there, but we changed this improper to a mixed number with a whole number. So we need to add these two whole numbers, 5 and 1, to get 6. And our fraction will remain the same here. So our final answer is going to be 6 and 1/12.